When I was an undergraduate student, I went with my friend to Mongolia. When I woke up at night, go out of the tank, I got shocked completely because there's just gigantic number of stars, millions of stars above my head. And also there is a shiny belt across the horizon. That is the Milky Way, the galaxy that we live in. Galaxies are giant collections of stars that can be up to like 100 billions of stars, for example, in the Milky Way, which is much more than the number of people in the Earth.
Galaxies are a collection of stars, planets, black holes, nebulae, and dark matter. We live in a galaxy that we call Milky Way. And by studying Milky Way in particular, we can learn about galaxy formation and evolution in general, because we can study our own galaxy in more detail and we have more precise data about it.
The Milky Way galaxy is a spiral galaxy. If you could see it, unfortunately we can't because we're inside of it, but if you could go far away and take a look at it, it would have these beautiful spiral arms. Now, not all galaxies look that way. And one of the kind of interesting questions we have in astrophysics is trying to understand why galaxies like the Milky Way look the way they do, while other galaxies look a lot less spectacular. There are galaxies out there which we call elliptical galaxies, which kind of just look like a big blob of stars, maybe like a football or a rugby ball or something.
The big question that we're trying to answer at the Institute for Computational Cosmology is how galaxies form and evolve, as well as how the structure that we observe today in the universe came to be. For this, we use large simulations that have been run on big supercomputers to build our own virtual universes, which we can then compare to the real one to learn more about the mechanisms and the processes that drive its evolution.
In a simulation, what we're trying to do is essentially recreate something the universe does, but inside of our computers. And so an example people might be familiar with is the weather forecasts. So there we measure what the weather's like now, and then putting in all the physics that's important for the way the weather evolves, so say how clouds form, what makes clouds turn into rain, we can predict from the weather now what the weather should be like in the future. And that's something that we do, but not on the scale of the weather or the Earth, on the scale of the whole universe.
An important power of simulations is the fact that we can look at astrophysical processes in time, and in particular we can look at the past. Whereas when we observe galaxies, for example stars in our own Milky Way, we only see where they are right now and how they are behaving right now.
In order to understand how the galaxies form, we need to use supercomputer, which is a computer 100 or even 1,000 times bigger than a normal desktop computer. We use this supercomputer to do simulation, that is to try to reproduce a realistic galaxy with simple principles and models. Simulation is never straightforward. It requires a lot of trials and errors. Astronomers can actually produce correct number of stars in galaxy, but many mysteries remain. For example, how does galaxy look like? How does them compare to the realistic looking galaxy? Another one is that how one galaxy can affect another galaxy too. Astronomers are just normal people. They can make mistakes, but they learn from their mistake and build up a better model. So step by step, we are making a better understanding of the universe.
So it's quite difficult to choose a single galaxy to be my favorite because there's so many millions and billions of them out there that it can cater to any sort of taste. But in general, I do like spiral galaxies, which show prominent spiral arms as well as magnificent stellar bars. But if I had to choose a single galaxy that's my favorite, would be the Sombrero galaxy. I really like the fact that there's this wonderfully thin disk of dust, as well as the stellar halo surrounding it. And I think it just embodies the definition of beauty and simplicity when talking about galaxies.
I'm an astronomer because I'm curious about how universe works, what are the laws of nature. I like to learn about how universe evolved, how galaxies inside the universe formed and evolved, and ultimately from these we can address questions that humans have been asking themselves for hundreds, if not thousands of years, about where humans are coming from.
What made me want to become an astronomer? I've always been interested in science since a very young age, and astronomy tries to answer some of the biggest questions out there. For example, what happens when two galaxies collide, or where did the supermassive black holes at the centers come from? It's these sort of questions that made me want to learn more about it. And when I first studied physics in high school, that's when I learned that we can model the physical world using mathematics and try to answer these sort of questions.
Why is astronomy important? Well, for me, the reason it's important is that it answers some of the most fundamental questions we have as human beings. So particularly the part of astronomy known as cosmology, which is what I primarily do, is trying to answer questions like, how did the universe come to be? How old is the universe? What's its eventual fate? and what are the kind of laws that govern the way the universe evolves. And I think if we want to understand why we're here and our place in the universe, these are some of the most important questions there are.